Why does everything decay into lead? Uh, this video is presented by Science. So, in the natural world, some elements like uranium and thorium are radioactive. And this means their atomic nuclei are unstable, and they spontaneously decay over time. The reason why of these radioactive elements eventually decay into lead has a lot to do with the stability of the atom's nucleus. So, radioactive decay is when an unstable atomic nucleus loses energy by releasing particles or energy. When a nucleus has too many neutrons, it becomes unstable, which means it tries to break apart to become more stable. So, as part of this process, this atom emits radiation like alpha particles, which are tiny clusters of two protons and two neutrons, or beta particles, electrons or positrons. This is a natural way of trying to fix the instability. So over time, as the nucleus keeps decaying, the atom changes into different elements. So there are very heavy elements like uranium or thorium end up as lead. For example, uranium-238 is a very heavy element, and it is unstable, so it starts decaying by emitting alpha particles. As it decays, it turns into other elements like thorium, radium, and eventually after several decades it becomes lead, specifically lead 206. This process is called the uranium decay chain. So lead, especially 206, is more stable because it has the right balance of protons and neutrons in its nucleus. So protons are positively charged particles in an atom's nucleus, and neutrons are neutral particles. For an atom to be stable, the number of protons and neutrons need to be right. So for example, lead 206 has 82 protons and 124 neutrons, which is a very stable combination. This is why after a series of radioactive decays, elements like uranium, thorium, and radium end up as lead. So to understand how long this process takes, we need to know about half-lives. So half-life is the time it takes for half of sample of radioactive element to decay into another element. So this decay process is incredibly slow, and it is only after millions or even billions of years that the element eventually decays into lead. So lead is not just stable, but it is also important for scientists who study the Earth's history. Since lead is the final product of many radioactive decay chains, scientists use lead isotopes to date rock, fossils, and minerals, which is also called radiometric dating. And that helps scientists understand how old a rock or fossil is by measuring the amount of lead and other elements left behind from the decay process. So in conclusion, why does everything decay into lead? The answer lies in the stability of lead. Many heavy elements like uranium and thorium start as unstable radioactive atoms. They go through series of decays, emitting particles and changing into new elements until they finally reach lead, which is one of the most stable elements. Once they become lead, the atoms are stable and won't decay any further. This process takes long time, but it is a natural way for the universe to balance out and reach stability. Lead stability is what it makes such an important marker for understanding the age of rock and minerals. Without this natural process of decay, we would not be able to measure the age of the earth or track the history of life on our planet. By understanding why elements decay into lead, we get a deeper understanding of how nature works, how elements interact, and how our planet has evolved over billions of years. Lead may not be the end of the story for everything, but for many radioactive elements, it is the final chapter. And as I said before, why does everything decay into lead has a lot to do with the uh, stability uh, stability of lead.